These linear programming problems, what we're trying to do is build some inequalities that show these different limits or constraints, and then we're going to see how those limits affect some objective or something. Usually it's profit or income, but it doesn't have to be that. It can be other things. So when I'm reading this problem, I'll about to give you a minute to read it. There's two kinds of biscuits you're making, jumbo and regular. Now we could certainly use X and Y, but to help me stay in context, I'm going to use J and R. So they're telling me, let's see, the most they can make are 400 biscuits per day. So I know that the number of jumbo biscuits plus the number of regular biscuits has to be less than or equal to 400 biscuits. And then for every jumbo biscuit, let's see, a jumbo biscuit requires 2 ounces of flour. So 2 times every jumbo biscuit plus 1 times every regular biscuit has to be less than, I don't have any more than 5 ounces of flour to use. So those are the two constraints they've outlined for me here. The other thing to worry about is, sorry, not X, but J. I have to make more than 0 biscuits, or at least 0 biscuits, right? It won't let me erase that X. So I know that the number of jumbo biscuits has to be greater than or equal to 0. I also know the number of regular biscuits has to be greater than or equal to 0. In other words, I'm only going to be working in the first quadrant. So a couple of ways to go with this. I like to make a picture. I'm going to put the jumbo biscuits on the x-axis, the regular biscuits on the y-axis. That doesn't really matter. Using graph paper often helps you do this also. So now we're going to talk about how do we graph this. Well, one way to graph these is to think of finding the intercepts. If I'm looking for the j-intercept for the number of biscuits, r is equal to 0, right? So I know that I have to have, when r equals 0, I can make 400 jumbo biscuits. And when j equals 0, I can make 400 regular biscuits. So I've got this inequality, and technically I have this shaded, here let me shade, I've got this shaded area. So that's any point in here, it satisfies this inequality. I mean, if I make 300 jumbo biscuits and I make 50 regular biscuits, I'm in that region. I could also make 100 regular biscuits, and that would put me right on the line. Okay, so this is called the feasible region, or part of the feasible region. Okay. So now the other inequality is, let's see, when j equals 0, r equals 500, so I'm way up here. When r equals 0, it's going to be 200, it's going to be 500 divided by 2, which is 250. So that means I'm going to cross, now you can see why with graph paper it's a little easier. So here's this inequality, and I'm going to shade that with blue coming down. So where's the feasible region? Well, the feasible region is the place, the possible values are all these places that are double shaded. So I'll darken that up. Actually, why don't I use black ink for that? Okay, so this is the feasible region, and then somebody found out that was studying this is that these corners of the feasible region are the possible values that maximize or minimize our answer. It'll be one of the answers. So the possible answers are 0, 400, 0, 0, which usually isn't one we want to use. I see 300 and 0, and then I see this intersection point. Now I got to find that intersection point. So we're going to do that using the solving a system of equations. I'm going to do that on the next. So I'm going to choose to use, I'm going to pretend these, remember when you're solving inequalities, linear inequalities, you can just pretend that these are equal signs for a few minutes. So I'm gonna multiply this top equation by -1. I better do this right. I always just write one set of parentheses, and then I get yelled at by people. So -j minus r equals -400. So that tells me j equals 100. And then to find r, I know that 2 times 100 plus r has to be 500. So that's 200 and that's 500. So 500 minus 200 is 300 ounces of flour. So that tells me that other point was 200. I'm sorry, 100, 300. So we've got 0, 0. We had 0, 400. We had 100, 300. I think what was the other one? 300. I'll have to look it up. It was 300, 0. So these are the 4 corner points, or the four possible answers, and one of these will maximize their income. So now let's talk about what they're going to maximize. Okay, so the objective function is income. And I know that I'm going to make it 13 cents, or bring in 13 cents for every jumbo biscuit, and 6 cents for every regular biscuit, and that's equal to my income. And I want to get it so my income, whatever combination of jumbo and regular biscuits I use, I want to get the maximum amount of income. So these are the values, and what I'm going to do is I'm going to replace each one of these J's and R's with the combination of points. And it makes sense that if I don't produce any biscuits, I'm going to make 0 income. So that one's out. On the next one, 13 cents times 0 plus 6 cents times 400. Let's see if I'm doing my arithmetic right. I think that's $24, right? And then 13 cents times 300 plus 6 cents times 0 is going to be what? $39. And then if I take 13 cents times 300 plus 6 cents times 400, that's going to be $63. So looks like that combination is going to be the one that's going to maximize their income. Now, some shortcuts to all this. Often when you're given one of these problems and you get that point in the middle, it'll be that point that gives you the answer. It gives you the maximum. Not always. That's why you want to check them all. The other thing that happens if I have more than one corner, like if I have more constraints, I might have some corners like that. You got to test those. You got to test those other points. Okay, but that's the process. Set up your constraints, figure out your solutions, places with all those corner points, and then plug them in your objective function. So I hope that helps.